So we've seen some of the problems with using touches. First is that there's a lot of different things a user might be doing. It's very complicated to support, for example, simultaneous tracking, pinching, zooming, swiping, rotating, and tapping all at the same time with the same methods. So if you were to make a diagram of all the possible states for a group of touches, you could quickly reach a very, very confusing state that would not be a easily maintainable piece of code. The other issue with using touches is sort of a future problem. So for example, if I have a single tap action and I have a double tap action, I don't know if something is a single tap until after I know that it isn't a double tap. So for example, if I double tap, I actually have two single taps and a double tap. So that also makes figuring out user interaction somewhat difficult. So what is the answer to this? The answer, or at least Apple's answer, is UI gesture recognizers. And Apple has a bunch of these pre-made for you. The first is pan, and that's what we just did in our moving the UI image view around. So pan allows you to move or drag a view from one place to another. There's rotation gesture recognizers, pinch recognizers, so for zooming in or out. There's tap gesture recognizers for single taps, double taps, triple taps, or whatever you would like. There's swipe gesture recognizers, and these recognize quick drags in a given direction. So a quick swipe up would be a swipe, and you would decide that it is not, for example, a pan gesture. And then the last gesture recognizer that Apple provides is a long press gesture recognizer. So if the user has put their finger down, hasn't moved it, and held it in the same place for a given amount of time, the gesture recognizer will recognize a long press. And the last thing to know about UI gesture recognizers is that they're subclassable. So you can make your own subclass of a UI gesture recognizer that recognizes a specific gesture that you would like. For example, you could have a gesture that recognizes whether the user is making a circle shape or whether they're drawing a square quickly, for example. Let's understand how gesture recognizers work. The first thing to know is that they're attached to a specific view. So each view gets or can get a specific gesture recognizer, or more than one. And the way that the iOS calculates the gesture recognizer to that view is it's hit tested. So it does something similar to what we did in our UI touch code, where we tested to see whether the user was in the specific view we were interested in. Now, even though a gesture recognizer is attached to a specific view, it can send action methods to any Objective-C object, such as a view controller, another view, anything you want, a gesture recognizer can send an action to. Now, the thing is you can have multiple recognizers in the same view, and that's really the key benefit of a recognizer, because you can detect more than one type of user interaction without writing a ton of code to calculate that. And each gesture recognizer acts independently of the others. And what I mean when I say each gesture recognizer acts independently, with a given touch, so if the user puts two fingers down on the view, all the gesture recognizers in that view get access to those touch events and will independently calculate whether those touch events are gestures. Now, once a given gesture recognizer recognizes those touches as a gesture, various things can happen. It can shut down the other gestures. It can keep the other gestures working or just some of them working. But as they process those touches, every gesture recognizer gets a chance to detect a gesture. Now, how do gesture recognizers do this? Why is this a better model going through this code where you detect a touch and decide what it does? So the thing that makes gesture recognizers most powerful is that they have a state. And that is what makes them better than just going through touches and calculating them in with a view. And for every gesture recognizer, you have a default state of gesture recognizer state possible. That's the default state. So most gesture recognizers spend most of their time in this possible state. And that essentially means that nothing has happened yet, but if touch events come in, they're going to process those touch events and figure out whether they're gestures. The next state that they all have is canceled. So what gesture recognizer state canceled means is that we thought it was a gesture, but we decided that no, this turned out not to be a gesture. The next possible one is it failed. And failure, it makes it sound as though it's worse than it is. What this means is it decided that the touches that the user just made were not the gesture. So for example, if you have a rotation recognizer and the user taps twice on the screen, the rotation recognizer will fail. And that just means it decided that's not a gesture that it's interested in. Now, if it did recognize a gesture, especially, for example, a single gesture recognizer like a tap or a swipe, it will immediately go into state recognized. So if someone taps on the screen and it recognizes that state as a tap, it'll be recognized, and then it will immediately end the recognizer state, reset, and go back to state possible. We're not even through with all the states yet, but all of these states can seem sort of complicated, but they're very important when you actually go to code, because you're going to want to make sure that these gestures don't interfere with each other. And when you have a lot of different possibilities in the same view, for example, if a gesture is rotating, and it might also be pinching, and it might also be moving, you want to be able to keep track of all these states so that you know that a gesture isn't going to interfere with another gesture. Now, rotations, pinches, and zooms, pans are all what are called continuous recognizers. And they have additional types of states. So unlike a tap, they have a recognizer state begin. So the user began to rotate something. That allows you to set up any variables you might want to track as the user manipulates an object. And then these continuous gesture recognizers also have a changed state. So as the user is rotating something, you continually get updates with the angle of rotation. And last, eventually a rotation will end. And that's when the gesture recognizer says that either there aren't any fingers on there or they're no longer a gesture. So the gesture ended. Now, in addition to these states, recognizers also have properties and methods that you can inquire about them. So there's the state, which we were working on. There's the view, and that's the view that the recognizer started in. So the user could actually drag outside of the view, but the recognizer will always recognize the starting view for a gesture. You can also enable or disable a recognizer. And you can ask the recognizer information about where it is in a view. So you have a CG point, location, and view. This is similar to what we did with touches. And what this tells us, for example, in a tap, it tells us where the user tapped. In a rotate or a pinch, it tells us the centroid of where the user is rotating or pinching from, which is what you will normally want. You can also inquire from the gesture recognizer how many touches are currently being used. And each gesture recognizer also has specific information for the type. So rotation recognizer gives you the angle of rotation. A pinch or zoom recognizer gives you information about the current scale of the pinch. So that's a lot of information to remember about gesture recognizers. Next thing we'll do is go into a demo and see how all of these work together in an image view. So earlier we had manipulated our image view using this touches moved event. But now, because we have gesture recognizers, we're going to not need to use any of these methods. I'll delete them. And just to clean up some of the stuff that we had before, I'll just delete anything that we're not using in this app so we have more space to show you the demo. So we have our image view and we still want to manipulate it, but this time we're going to use gesture recognizers. So I'll add a gesture recognizer here. I'm just going to make this a generic method, add gesture recognizers. And the first thing we want to do is duplicate that pan gesture recognizer, or the slide around the screen gesture that we did earlier. And that's called a UI pan gesture recognizer. So I'll create one of those. UI pan gesture recognizer. Call it pan recognizer. And we just create these like we create other Objective-C objects. We allocate them. And we're going to initialize them with a target and a selector. Every time something changes on every time there has a state change on the pan gesture recognizer, we want it to call a target and call the selector for that target. So the target is just self, so it's our class, and the action is @selector, and we'll just say pan recognized. And I add this colon after it because we want to pass the pan recognizer along with this method. I'll show you how that works in a second. So let's create the method right off the bat. So void pan recognized. So what I did is I created a method called pan recognized, and I know by default I'm going to get the pan gesture recognizer. And I did that just by adding the colon here, and the method knows to pass itself if it's going to a method that takes one argument. So now I've created this pan gesture recognizer, I just need to add it to a view. And because we only want to move the image view, and we know that the gesture recognizer is hit tested already to that image view, instead of adding it to our main view like we did with other class, we will just say self.imageView, add gesture recognizer, pan recognizer. So now our image view in our nib file, this one right here, has a pan recognizer attached to it. And to make sure this happens, we added this method here. When the view loads, we want to automatically add the gesture recognizers. And I'm using plural here because we're going to add more later. Let's look at what happened so far. Our view loads. Once we have all the components of our view, we call this method add gesture recognizers. We create a pan gesture recognizer, which detects drags across the screen. We send every time it has a state change. We have it target our class and call the method pan recognized. And actually, it's targeting the instance of our class. And it calls the selector pan recognized, which is this method right here. So now that we have the recognizer working, we actually have to move the image view. And the first thing I'm going to do is grab an instance or a handle on the view that the recognizer recognized a pan on. So I'll just call this pan view equals recognizer not view. So earlier we said that recognizers have certain attributes or properties. One of them is the view that they belong to. So this is going to give us back our image view. And the reason I waste a line of code here, I use a line of code, is I could directly call this image view and just know that it happened to be the pan view. But that only works if I only have one that I'm interested in. So I don't want to hard code which view I'm interested in, because we want to make this flexible if we want to add more views to our class. Now, just like I did with the touch methods, I need to get a point and a difference in the point of how much the user dragged. So the pan recognizer has an easy method for that. Returns a point that has an x and a y delta. It's called a translation. And we just ask our recognizer for a translation in the view. And we always, not always, in this case we are going to be using the super view. In most cases it's a good option. So you have panView.superView. So that just gives us the translation of the view that the pan view is in. Now we have a delta x and a delta y for how much the pan view had moved in the super view. We don't use the image view here because if we're dragging the image automatically, the translation in the view isn't going to be right. So you want to use the super view or possibly some other view. Now we just need to do the same thing we did with the UI view. We need to move the view over by the delta. So we'll do the same method. Pan view center equals CG point make. And we get the current center for the x value, and we move it by the delta. So translation dot x. And same for the y, panView.center.y, and we move it over by the delta y. So let's build and run that and see if we can spot any issues. So I'll click and hold and start dragging on this image view. And nothing is happening. And the reason nothing is happening, and you'll run into this in a lot of different cases, in this case it's because our UI image view does not have user interaction enabled by default. So that is preventing our gesture recognizer from working. So the easy thing to do is in the viewDidLoad, say self.imageView.userInteractionEnabled equals yes. So that should solve that problem. So let's build and run again, see if there's any other issues. Oh. It dragged it way faster than I was expecting. So I started to drag it. It started moving slowly and then quickly accelerated out. So let's see why that might be. And again, I'm going through all these errors because they're very, very common, and you'll run into them and you'll know what it looks like on the screen so that you'll know what the likely problem is. In this case, the translation is a cumulative translation, and we're treating it as an incremental change. So this delta right here is the total delta since the first instance that the pan recognizer was recognized. So at first, the first time it's called, the translation is just the delta. But the next time it's called, it's a delta plus the previous delta, and the next time it's called, it's a delta plus the delta plus the delta. So you get lots of additive delta, and that's why you see that sort of accelerating, disappearing off the screen. And there's a lot of different ways people fix this. Sometimes people just add some instance variables and calculate out what the translation total is and just add that to the initial center. But the easiest way to do that and the simplest way to do that is just to reset it. So this will make your code a lot cleaner, and it's, in almost all cases, it's what you want. So in this case, we're going to say recognizer, and we're just going to reset that translation. So set translation, CG point, we could use CG point make, but we'll just use automatic CG point 0, and that CG point 0 is equivalent to CG point make 0, 0. But this is cleaner. And we want to zero out the translation in the same view we had before. So pan view.superview. So now we've prevented this cumulative effect from happening. And let's go back in our code and see what happens. Okay, now when we drag it, it tracks the mouse, and it does not accelerate off the screen, and it moves. So to make that happen, we had to make sure that the user interaction was enabled on the view that had the gesture recognizer, and we had to make sure that we were resetting or somehow calculating the translation. So we either need to calculate the cumulative translation, or we need to reset it after each call. Now we could also, if we wanted to set some, we're not going to do this in this case, but if we wanted to set some variables when the recognizer started, we could do something like if UI gesture recognizer state begin equals recognizer.state. So if it just began, we could do something. You could also have an ended state or a change state, any of the states that we had before. So you can set these to change based upon what state the recognizer is in. So for example, if once a user first starts dragging, you might want to change the image somehow to make the user know it's selected. And then when the user is done dragging, you might want to change the image again to let them know that it's currently in an unselected state. And you can do all that by using the state of the gesture recognizers.